Okay, we have here today another interesting integral. This one's from the MIT integration, should be 2024, problem 14. We have the integral from 1 over e to e, 1 minus 1 over x squared, e to the e to the x plus 1 over x dx. Okay, this problem gave me so many things to worry about. I wasn't sure if I was even going to do it because there was too many concerns with the graph and with dividing by 0. We have this divide by 0 problem here. So we can see just from here and here there's going to be a vertical asymptote at 0. But we're actually fine because our bounds start at 1 over e. E is something like 2.718 something. 1 over e is something like 0.36 whatever. So our bounds don't include 0, so this is not a problem. But then the other thing you'll notice, if you plug in a 1 in for x, this piece here is 0. If you look at the graph of this at 1, it looks like almost a vertical asymptote at 1 because you have this where it's definitely 0 at exactly 1. But then above and below 1, this thing here is blowing up so fast because of the exponential. And then the last thing I noticed is we kind of have an obvious u substitution here. If you just take the derivative, we called this piece our u, we have the derivative of this right here. But I also noticed that we have the situation where our bounds are just the reciprocal of each other. If we take the reciprocal of 1 over e, we get e. And so that's what I want to do for my u substitution. Actually, I'm just going to use these bounds, and we can do a u substitution for 1 over x. And then just solving for x, we find x is 1 over u. I'll take a derivative of this. So we'll find dx is going to be minus 1 over u squared du. So then I'll just go ahead and make the substitution. And again, with this substitution, it's just going to flip our bounds around. So the upper bound is going to become 1 over e. The lower bound will become e. Then this part here, we have 1 minus, plugging in x here, it's going to give me 1 over u squared. It'll flip it, and we'll end up with just 1 over u squared here. And then this thing, we're going to end up with e to the e. And this is going to become, I can write it as 1 over u plus u, but let's just change the order and write it as u plus 1 over u. And then here, and then for dx, we'll have all this stuff, so we'll have minus 1 over u squared du. I'll take this minus sign, bring it out front, and use to flip the bounds. So we'll just rewrite this here. And then let's take this 1 over u squared and distribute it in here. So basically what's going to happen is it's going to cancel with this and make this a 1, and then this here will become 1 over u squared. But then what I want to do is swap the order here. So what I can do is change the sign. I can write this as 1 minus 1 over u squared, but I don't want to change it, so I'll just bring a minus out front. And now one last thing I want to do a variable change. I'm going to switch the variable back to x. It's a definite integral, so I can switch it back. So let's just change this, rewrite it, and put everything in x. And now with this rewrite, what you'll notice, this right here, this is exactly our original integral. I know I've messed this up, but this is the exact same thing as what we had originally. Keep in mind that we've got this minus in front. So just to finish this off, we'll label our original integral I, and we just manipulated it down to this version of I. But again, this right here is I. So what we've done is we've created this equation where I equals minus I. Just to be real clear, I'll add an I on both sides, right? Add it here and here. On the right side, it's going to cancel, and we have 0 here. And then on the left side, we have 2i. But the only way this works is if I is just equal to 0. So there you have it, kind of an unusual problem. And again, it's still troubling because if you look at a graph of this, it's hard to see how it's 0 where you have like basically a vertical asymptote in the middle of this thing. So there's no I don't see any visual way to see how this is 0. But it does make sense and it matches the MIT solution, so I think we'll take it. Thanks everyone for watching. Have a good day.